tell me if this moves on. Is that moving?
Okay, yeah, we don't have the Hawthorne effect.
So the Hawthorne effect is where the experimenters themselves had an effect on the outcome, right? The fact that, you know, in the Hawthorne experiment, people were looking at whether changing work conditions, like lighting hours when they had rest breaks, whether that would have an effect. And everything worked, right? And it turned out that the experimenters themselves were having an impact. The workers were so pleased that someone was concerned about their working conditions that everything that the experimenters did, everything they did resulted in an increase in productivity. So that's an example where extraneous effects weren't accounted for, and you wouldn't have thought the fact that you were there as the experimenter doing the research that you would have had such a big effect, right? So that's an example of an extraneous effect, and you've got to be very careful that, for example, that you as a researcher don't affect the outcome. Replication can be very important because that reduces the amount of experimental error. So don't just run the experiment once, you can run it multiple times and then take the average of the effect of the X variable on the Y variable. Yep. And so that gives you better control of experimental error. And randomization can help you account for this extraneous factors, right? So even if it's a matched pair, right, where you match on age, sex, age, etc., you may have missed something that was really important, right? So to better control for the extraneous factors, putting people randomly into the control and treatment group is one of the best ways to control extraneous events. Internal validity. We'll talk about internal validity and external validity. Internal validity is the ability of the experiment to answer the question: was it the treatment that caused the difference in results? So did the manipulation do what it was supposed to? So things that help increase internal validity is having a control group as well as a treatment effect, randomly assigning individuals to the treatment and control group, and pre and post testing. External validity is about whether the results can be generalized. I got some results from this experiment or the sequence of experiments. Can I now go out and generalize them to the whole population? So one of the things here is using students, right? Researchers have got very easy access to students, right? So is that, does it only really work if you use students? Are your results only really applicable to students? Well, lots of arguments here, and we'll come back to it again later. But students around the world are fairly homogeneous, right? And that does allow for easy replication. You do the experiment in Australia, you do it in Vietnam. The students are, students are students. They're also very smart, and they can understand abstract instructions and complex problems quickly. So that isolates one potential extraneous event, right? That is participants' confusion, right? You've got smart people doing as subjects, right? They can quickly understand the instructions you give them and the complex problem you've given them, right? So that eliminates confusion that others might have. And you can certainly use non-students if possible, right? You just find the research harder to do, right? Because the people that are working in industry or in business, their time is precious to them, so it's harder to do. But we'll come back to that as well. So that's one of the issues for external validity. So just recapping, we could do independent trials. So we have one group getting the treatment, the other being the control. So here we've got the 2 hours sleep versus 10 hours sleep, and we could do different participants randomly allocated to each group. That's independent trials. We could do repeated trials where it's the same people and they first do the 2-hour sleep, and then they do the 10-hour sleep. Yeah. But if we're going to do that, there's possible order effects. So, we might have one person do 2 hours, 3-hour sleep, and then 10-hour sleep. But the next participant, we get to do the 10-hour sleep first and the 3-hour sleep. Yeah. So you would vary the order of treatment for the participants. And then finally, what you can do is match samples, right? You use similar but different participants, right? And you might match them on, for example, their age, their gender, and their health. So they're the 3 predominant ways to do it. Yeah? Independent, repeated, or matched samples. Helps to understand historical origins. So experiments trace right back to Bernoulli in 1738. Chamberlain is a very important figure in the history of modern experiments. Yeah. And he published a study in 1948 in the Journal of Political Economy, which is one of the big majors. And interestingly enough, remember I showed you the Nobel Prize winners earlier. Vernon Smith was one of the Nobel Prize winners. Well, he was actually a participant in Chamberlain's as a student. Right? Vernon Smith was a participant in Chamberlain's 1948 experiment. So you can say that Chamberlain was sort of the father of modern experimental methods. So issues. Yeah. So one of the issues that your referees or your editors might say is one, students. Yeah. That you're using students rather than people from the real world, and that there's not a lot of stake. Not a lot of stakes in the laboratory experiment, right? So they say, well, you're using students and they're not playing for, sheep stations. They're not playing for a lot of money. They're not playing, they're not actually, you're not able to replicate, the rewards they get in the real world. But Vernon Smith has a really good argument for that. And he says that the laboratory becomes a place where real people earn real money for making real decisions about abstract claims that are just as real as a share of General Motors. Yeah? So Vernon Smith argues that you do have real people. You do, in doing experiments, you do pay people to do the experiment, and what you pay them could depend on the outcomes. Yeah? And of course, what you've got is an abstract claim, or the dependent variable might be abstract, but so is a share of General Motors. Right? It's a share of a joint stock company. Right? It's quite an abstract thing when you think about it. So just going back, you do have access to students. They're homogeneous. That allows around the world, that allows replication. And just as we said before, they are very smart and can understand. So that gets rid of one of the extraneous factors that you might be worried about, which is confusion on the part of subjects. And